Thank you. So here at Trainline, so yes, here's the thing I was going to run through today. So we'll be talking a bit about our use of big data, and I'm going to talk first of all about our technology for that, in particular our use of cloud and serverless in the cloud for big data and data science. Then Marco will talk a bit more about some of the data science products that we've developed. And so at Trainline, our mission is to help our customers to make smarter journeys. And that means helping them save time, money, and energy. And we're big believers that data can play a big part in that. And the other thing I'd like you to pick up on here, we've got some facts and figures about Trainline, is that we're a pretty big e-commerce company. We have a lot of visitors, a lot of hits to our sites and commercial transactions. And this means that with our customers' permission, we have the opportunity to analyze and find patterns in a great deal of data. And we believe that finding patterns in that data, we can make data products that will make train travel nicer for our customers. So we've got a great deal of data, and obviously we're going to need a huge computer to process this all on. And you know, certainly back in the 1980s when I was a student, and there I am actually, there I was a student back in the 80s. Yeah, you would have needed a massive computer to work with data. Something like this. This is a computer from my student days, Cray supercomputer. Personally, I love the aesthetic of a computer that's so big you can use it as a practical piece of furniture. But obviously this thing was very expensive, very exotic, very few people had access to it. And things have moved on. So now we have the modern era, and we have racks of relatively inexpensive commodity hardware, this kind of thing. And the software that we use to do big data at Trainline, and more widely, as you know, is things like Hadoop, open source software that works very well on this kind of commodity servers, racks of commodity servers. And that's the stuff that we use. And it sort of moves on from there as well, because we now move into the cloud era as well. And at Trainline, we use Amazon Web Services as our cloud provider, both for our apps and websites, but also for big data. It works extremely well for us. I actually think that big data, data science, and cloud are a really good pattern and a really good match for each other. And something that we routinely do is start up clusters of 20 or 30 EC2 instances on Amazon, process some data, analyze it, save the results to S3, which is Amazon's object store, and then we shut down those on-demand instances, stop paying money. It's a really good pattern for us. And you know, at times, certainly in the past, I've run Hadoop clusters of hundreds of instances. It's absolutely excellent. This guy is Bob Harris, who was my old CTO at Channel 4. And you know, when you're looking at different cloud options, I'd really advise you to think about what we call Bob's laws. Which is to say that it's only cloud if it's self-provisioning, pay-as-you-go, and to all intents and purposes, infinitely scalable. And so, you know, this means, is hosting cloud? Not really, because it's not self-provisioning. You have to, it's not pay-as-you-go. You usually have to get locked into a contract. Is enterprise cloud real cloud? Well, it's debatable, isn't it? Is it really infinitely scalable? It's a bit debatable. So, you know, if my top tip for you there is to think about Bob's laws. And it moves on as well. So, you know, this idea of pets, etc., is something that these are terms that Werner Vogels, the CTO of Amazon, has coined. And, you know, again, I think this is a progress that we're all seeing as well. So there was a time when we treated servers like pets. We used to give them names, and if they weren't very well, we'd sort of lavish time on trying to sort them out, repairing them, and what have you. We're now doing a lot of our work in virtual machines on Amazon. That's EC2 instances. And that means that if they're not working correctly, we just kill them off and create another one. It's quite brutal, but it saves a lot of time and means we're not doing a lot of systems admin stuff. And the progress moves on. You know, now, and I'm going to be talking about this a lot in the rest of this talk, we're now moving on to what Werner calls herds of computers, so containers and serverless architecture. And this also links up with the sort of traditional hierarchy of infrastructure as a service, platform as a service, and software as a service. And you know, I want us to sort of think about these two things together. And you know, at Trainline, our preference is to go for platform as a service wherever possible, and also to go serverless wherever possible. And we do this because we think it saves a lot of time and money, and the TCO works out really well. And it means we can just get on with actually doing the tasks in hand. But we're not precious about this stuff. So If we find out that the PaaS service isn't powerful enough, doesn't meet our needs, then we'll revert back to infrastructure as a service and install some software on it. Similarly with serverless, we'll go back to single servers again. So let me take you now through some architecture that we have for big data. So this is a very high level view of how we process data. It comes from many sources through a data gateway, ultimately processed into a data lake, which in our case is S3 storage on Amazon. I'm going to expand now into that data gateway and tell you a bit more about it. So we've made our data gateway out of serverless, mostly PaaS services. So we take data via a REST API. We're using API gateway. We then do some pre-processing of it using Lambda, which is a serverless general purpose compute resource on Amazon. I'll talk a bit more about that in a moment. The data then goes into Kinesis Streams, which is a streaming service, again, platform as a service and serverless on Amazon, somewhat similar to Kafka, if any of you have come across that before. And then when people consume the data, we kind of do the opposite thing. So we use API gateway and then Lambda again to decompress and decrypt it and so forth. I can give you an example of how we use this. So we've written another service in Lambda called Glutton, and it reads data from our data gateway using that REST API that I mentioned earlier, and outputs it to S3 storage. And so we have a really nice thing here where services around Trainline can put data into that can be producing services, put it into our data gateway, and the data is available to other people who want to. It's like a publish-subscribe model, but also the data gets persisted into S3 using that Glutton thing that I mentioned there. Another example of this kind of serverless approach is our data platform itself. So this is data products that we've developed. Marco will be telling you more about those in a moment. And again, very similar sort of pattern. At the bottom here, we train our models using Elastic MapReduce mostly, sometimes R as well. Store the models on DynamoDB, which is a serverless NoSQL database that Amazon have. And then we have Lambda and API gateway again to provide those data products, things like BusyBot and so forth, via a REST API to other parts of Trainline. So let me now zoom in a bit on some of these serverless things that I was talking about. Lambda, if you haven't tried it yet and you're using Amazon, I think it's really great. I think it works really well. It gives you the ability to concentrate on making some code and then deploying it on what is presumably at Amazon an enormous number of servers, an enormous Lambda farm that they have, and then basically forget about it. They do all of the administration and running and scaling of that for you. And so I can tell you, for example, that we have some functions we've written, deployed them on Lambda, and that during busy times they scale up to what seems to be several hundred instances of little Lambda machines running these things. And then in the quiet times, it scales all the way down to virtually zero. And of course, you only pay for what you're using. So it's incredibly cost effective and really easy to use, nothing to administrate really. So generally very excellent. A few things to bear in mind though. One is that because Amazon are starting and stopping these things for you, you need to be aware of the warm-up time for your Lambdas. So how quickly they get started will be depending on the language and framework that you write them in. So we've written some using Java, and the JVM takes maybe about 5 seconds to get started, which, you know, is, in terms of an API response, that's quite a lot of time. On the other hand, when we've written them using Python, it's a much smaller framework and they start up in just a few hundred milliseconds. So be aware of warm-up time. Also be aware that Lambda is intended for little functions that get started, do something, and then shut down. And when they shut down, the Lambda machine freezes. So the consequence of this, we find, is that you can't sort of start other threads and expect them to carry on running after the main thread stops. So things like doing monitoring, calling, we use New Relic for application monitoring at the moment. So things like calling that on a separate thread don't really work out, so you have to sort of engineer ways around this. But well, by the way, we have a blog post that explains this much better than I can standing here this evening. So by all means, Google that if you'd like more info about our sort of Lambda findings. Kinesis Streams, again, it's excellent, really easy to get started with. Again, presumably Amazon have an enormous number of servers and things running it for you. Once you set up a Kinesis stream, though, all you have to worry about is putting data into it, reading it out again, Basically, everything is administrated for you, very low total cost of ownership, really easy to live with. Generally inexpensive to live with. You just have to be very aware of what the costing model is, and it's basically a combination of the capacity you need, how many messages you're going to do, how big the messages are, and so forth. If it's important to you that no messages get lost, then you probably have to engineer some other things around it to ensure that. Like all of the Amazon services, it comes with CloudWatch, but we found that wasn't enough on its own, so we had to engineer extra bits. And there may be a case for kind of compressing and encrypting your data before it goes into Kinesis streams. Compressing it makes it smaller, which is cheaper, and encryption may have its own benefits, something you have to work out for yourself. So in general, actually, when you're using these serverless things, or anything on Amazon Web Services, I really advise that you look at this 75-page paper that they have about security. I think it's essential reading. And it's very boring reading, but really essential if you're using Amazon. So that's it for me. That's it for the data engineering part. I'll hand over to Marco now to tell you how we use this in practice for actual products. Okay, over to you.
All right. Thank you, John, for the nice introduction of our infrastructure. So I'm going to speak about BusyBot as a first case study or a first data product, or what we deploy on this infrastructure. So let's start from the problem. We all know that train journeys are not always pleasant. So there could be different problems. So from this survey, it was found that the main problems are delays, toilet facilities, value for money. But among these, there's also overcrowding, which is a very annoying problem. When you get on a train, you cannot find a seat, but maybe there is a seat at the other end of the train. So what happened was that last year, November, there was this Hack Train, which is an hackathon, but basically happens on a train while the train is moving. And there are, it's true. And there were like 120 rail tech innovators, and it lasted for 2 days. And some of our people went to this hackathon. In particular, one of them, Raul, which I don't think is here today, but yeah, he worked with a team to deploy the first version of BusyBot. And the idea was so good that they actually won the second prize at this hackathon. And when he came back to Trainline, the business was so excited, so we put some resources in it, and we deployed the first version of BusyBot. And the first version of BusyBot that was deployed in February 2016 was actually just a little survey that pops up from the bottom of your screen on the Trainline app when you're looking at your journey. So when you are in the live tracker and you're looking at your specific journey at the different station, there is this survey that pops up and asks you if you found a seat or not. And also in which side of a train you are, if you are in the back, in the middle, or in the front. So this was deployed only on Android, and the incredible thing is that in 3 months we collected around 100,000 feedbacks, and that's quite incredible because we weren't giving anything back to the user, so we were just asking for this feedback, and that's it. But they were happy to share it with us. So yeah, we were able to collect around 100,000 feedbacks. And then in the data science team, we started to look at this data, and we started one of these, what we call data discovery stage process, where we actually look into the data and basically try to find some insights or some opportunities that we can then share with the business. So what we did was basically to build a little dashboard that was showing, for instance, for some particular routes, what were the stations along the route, and which was the percentage of people who were getting a seat in the station in the different parts of the train. And we were also able to plot some nice heat maps to show in which days of the week and which part of the days it was easier to get a seat. So this was basically our way to communicate the findings, the insights that we got from the data to the business, and the business was really excited about what we can do with this data, and so we invested more resources to actually deploy develop the first version of BusyBot. But let's talk a little bit about how this is contextualized in what John said. So we basically start from the feedback collection. So from our app, we collect the feedback that gets stored in a DynamoDB production database. And then we have a daily process, which is part of the data gateway that John described, that basically gets this data and enrich it with reference data about trains and routes and stations, and put it on S3. So at this point, the data is still at individual levels. So you have the individual feedbacks for every customer, for every user, and you have basically in which part of the train they boarded and if they found a seat or not. So in this way, we are collecting now around 10 to 20,000 feedbacks every day. And if we look at the hourly patterns, you can see this like typical shapes. So you can see that these are basically days of the week. And you have the first one, which is a Friday with a huge spike on Friday evening, because probably a lot of people are going home. So they're checking on our app their train. And then you have on Saturday, which is a little slow. And then on Sunday evening, another peak, probably because people are going back to the city for a new week, for starting a new week. And then you have a typical shape for weekdays where you have spikes, basically, in the morning and in the evening. And if we look at the geographical distribution of these feedbacks, you can see that basically we can cover pretty much all the UK if we consider all the feedbacks that we collected. But of course, it's not enough to have like 1 or 2 feedbacks from a station to be able to tell something to our users. So we need to put some filters to let's say, keep only the station where we have a certain amount of feedback. So, but even if you filter from station with at least 100 or 1,000 feedbacks, you still have a good coverage. And in particular, one of the worst stations, it appears to be City Thameslink, close by, quite close by, where the percentage of getting a seat is only 50% overall trains, overall times, overall days. So, so what do we do with data that we collected? So we have a first model building and validation project, process, which is part of the data platform that John described. So we are basically getting the individual feedbacks and aggregating them at different granularity levels. So the one that you can see in this slide is basically a granularity level of route, so origin and destination, and then at the stop, the station level, and the part of the train. So for this granularity level, we can get the percentage of people who got a seat. And we can use this information to actually communicate with the client, with the app, and to basically say which is the best part to where you should board the train. We decided to pre-process all this information to basically have a quicker service that can respond to all the calls on time. So basically the service, all what the service has to do is to look up in this table that was pre-processed and basically recommend which part of the train is the best to board. So I mentioned that we also have a data validation step. And in this data validation step, we filter out data points that are noisy or like that are not really reliable. And the way we are doing it is to basically put some filters in place, like we want a certain amount of feedbacks. We want feedbacks for a certain number of days. And also we want at least a certain confidence interval around the percentage of people who got a seat. And for instance, in this plot, you can see different data points about different stations and on particular routes. And on the X, you can see the percentage of people who got a seat from 0 to 1. And on the Y-axis, you can see the confidence interval. So basically, we are dropping all the data points above the line because they're too noisy and the confidence interval is too wide, while we are keeping all these data points below, which are also the one, as you can see from the color, with the higher number of feedbacks. So the result of this is basically BusyBot version 1 that was deployed in September, like 2 months ago. And it actually comes in 2 flavors, but one is in production, one not yet. So the one in production is the one on the right, where you are on the live tracker and you're looking at your train. And you can see this little picture that tells you which is the part of the train with free seats. The other one, instead, is in the journey results. So if you look for a specific journey, you will see all the different trains that you can get, and some of them are marked as busy. So this could be very useful because maybe you're going to the station and you can see that the next train is very busy, so you can, I don't know, relax a little bit and get the next one, which could have a seat for you. So BusyBot is definitely not the only thing that we are doing. We have other interesting projects and initiatives. So one of them is about hotels. We have a partnership with Booking.com, and basically after you book a ticket with us, we also can help you to book a hotel through Booking.com. What we are doing is to basically analyze this data and try to understand who are the customers who are more likely to book hotels based on the journey they're taking and also based on what they did in the past. So we built a propensity model that takes this data into account, select the most likely customers and the most likely train bookings, and then send this data to our CRM team that can then contact them and try to sell a hotel. Another work that we are doing with the CRM team is around journey recommendations. So we have a monthly newsletter that we send to our customer. And in this monthly newsletter, we have some recommendations about journeys that you may like based on what you did in the past. And so we are looking at your past purchases and past behavior to try to recommend you the best journeys that you can take in future. And finally, this is very recent, we are also trying to predict what you're going to search, so especially in the app. So when you open the app and you maybe want to check times because maybe you're a commuter, so it's early morning, you want to check your train, if it's on time or not, you usually have to put origin and destination. So what we are trying to do is to look at your patterns, at your data that you gave us using the app to predict this search, so you can already find this field for you, and you don't have to fill it. And in the evening, when given the model should be able to predict that you are coming home, and so it should already predict you the right origin and destination to search for. So to summarize our talks, so John presented how we can basically build our architecture using serverless tools that are very useful for this kind of projects and initiatives that we are tackling. And in particular, we can see that most of the things that we are doing follow very similar patterns. So it's very important to get it right, so you can then replicate it to solve different problems. I spoke about BusyBot, I spoke about hotels, journey recommendations, and search prediction, but there are many other things that we are doing about delays, about prices, about personalization and real-time information. So I'm going to finish by saying that we are hiring, so if you're looking for a data scientist or data engineer position, please get in touch with our HR people. So there is Mali over there, and David, I don't know if he's in the room, probably not, but you have their contact there, or you can get in touch with me or the other Trainline guys in the room.